Evaluate the indefinite integral of e to the x plus e to the 5x over e to the x. This particular example is just making sure you remember that there's no such thing as a quotient rule for integration. In order to evaluate this, we have to do some algebra in order to rewrite it in such a way that we can use the exponential rule. So if you have a sum or difference of terms in a numerator, and you have just a single term in a denominator, you can split that up into separate fractions and simplify. So in this case, e to the x over e to the x is just 1. E to the 5x over e to the x would be e to the 4x. And if you're unsure as to why that is, go off to the side and figure it out. E to the 5x divided by e to the x. How do we know what that is? Well, we have rules of exponents. The rules of exponents say that if you have two exponential functions with the same base, we absolutely do. Their base are both e here. You can rewrite that as an exponential function of one single base if you subtract their exponents. So e to the 5x minus x. These are now algebraically considered like terms, and like terms can be combined. 5x minus x is 4x. And if you're still uncertain about that, use the distributive property. X can factor out of these two terms and leave you the constants 5 minus 1. And I think you can be pretty certain that 5 minus 1 is 4, so 4 times x. Now, the next stage in the process is to integrate. Integrating 1, since these two terms are added, we can integrate them separately. So integrating 1 is simple. It's just going to be x. But e to the 4x is a bit more complex. So let's go ahead and get started. We'll say this is x plus the integral of e to the 4x dx. I'll use u-Substitution. So that dx is 1/4 of du. So this would be x plus the integral of e to the u du times my constant of 1/4. So x plus 1/4 e to the u plus c. Everything needs to go back to the original variable. E to the u is 4x, so e to the 4x plus c. Now, as you get better at u-Substitution, one thing you can count on is if you are substituting with just a linear factor, that on the outside of your integral, you're going to have 1 over whatever that linear slope is. So you can start saving yourself a whole lot of time by recognizing those types of patterns, and instead of going through all these steps, going right to the solution. So the integral of e to the 4x dx, you should recognize as 1/4 e to the